So simply put, CDN is really to handle spikes. So when there's a lot of users hitting a specific web service, it could be game hosting, or it could be a web page. It's being able to handle for that huge spike. It also is for DDoS protection and also reducing latency. So basically, that's almost every service out there. If you have a web page, then you should look into a CDN to improve the experience for your visitors visiting your web page or whatever service that you have. Here in front of me, this is just a diagram of how content delivery would actually work. And so one of the most popular ways to do CDN is actually through container or Kubernetes engines. So we're really focused on the hardware, but we do a lot of reference designs with Kubernetes. So Kubernetes is a very popular engine for doing platform as a service to support microservices, and those microservices do include content delivery networks. So CDN is very popular for any web scaler. So if you have a website or you're doing video streaming, video game hosting, content delivery networks are very popular to handle spikes as well as security. During peak hours when kids get home, you'll have a big spike in users. So the hosting companies or the gaming companies, they need to have enough resources to really handle that amount of load and do it in a way where they have good response rate. So as a gamer, I know that firsthand because I'm like, what's going on? I'm getting 200 ping, and that makes a very bad gaming experience. You can see here on the right, we have a variety of different types of systems, from blades to standard rack-bound systems, multi-node systems. And so we're doing a lot of innovation there and looking at specific workloads and building hardware around it. So for example, if we're talking about content delivery networks, there could be a variety of different databases that are a part of the solution stack. So MongoDB is a very common one. DynamoDB, there could be in-memory databases. So all these different databases work together, and so there's a lot of different components that come into play to really accelerate these type of databases and workloads. So in this particular example, we're showing 12 NVMe in one node. We call this, in our multi-node system, this is actually a node, so the system can be managed from the rear side, and there's a lot of I/O, up to 200 gigabit per port, or per NIC actually. So there's be a dual 100 gig, for example. And so that's very interesting for customers that want to have NVMe over Fabric. Where in a system like this is our new Grand Twin system. So this is one of the first twin systems that actually has 16 DIMMs, and that's running on a single socket. So the innovation here is really reworking the enclosure to accommodate this much memory. And we're doing it in such a way where we can support up to 270 watts of power for the CPU, and eventually we can support even more. We're working very closely with both Intel and Red Hat on various reference designs, rack scale, as well as building block solutions. So one of the things that we're showcasing in the context of Mobile World Congress as a whole, as well as content delivery, is the ability to set up CDN POPs. You can see on screen, we have node A, B, C. So these nodes could be bare metal, this is A, B, and C, and that could be enough to actually spin up a Kubernetes cluster or OpenShift cluster. The other interesting thing is we have another node here, which could be the provisioning service, or they call it a bastion node. So for someone that would deploy this machine at a hosting location or in the cloud, this becomes a standalone unit to actually stand up a Kubernetes cluster without much additional components. Of course, you need a top-of-rack switch, like 100 gigabit or 1 gig for the dedicated BMC management controllers. But beyond that, that's all they need to really get started. So we're actually showing what it would look like to do transcoding on the fly. So a lot of ways that CDN companies are doing this, or let's say a set-top box company or ISP partner wants to deliver video, they'd actually do multiplexing. So the front end could be compressing the data, doing transcoding on premise, but to reduce the cost, they might offset their operation cost by doing it in the cloud as well. So you can basically have different slices of the video, and then you can, once the job is done, multiplex them back together and then stream it out to the end user. So that's the whole reason why we're trying to make it as compact as possible, is to make it easier to set up these CDN POPs.
Learn more at supermicro.com/MWC2022.